Okay, this is Mr. Peterson, and I'm going to take you through some examples for the Chapter 1 review in Algebra 2 and Algebra 2 Honors. We're going to start with example 1 here, and we're supposed to use the vertical line test to see if this is a function. So ultimately, we're looking for a yes or no on these problems. And all you do is draw vertical lines. So there's one. And if any of these lines hit the graph in more than one spot, it fails the test and it's not a function. So far, so good. We hit once. But if I come over here, you can see that we get three different y values when x is over to the right, about 0.8. But anyway, we get to three different places where it hits. This is one x value, and yet three different y values, so this is not a function. The abbreviation for function I'm going to use is FCN. In the next example, if you draw a vertical line here, it hits that green dot. That's just one dot, so far it's okay. But when I come over here to x equals 3, there's two places, two answers that associate with x equals 3, and so this is not a function. So we've had two of them that are no. And I've got another example here just like that. In this example, no matter where we slice it, we only cross that function or that graph once. Each of those hits just once. So it's okay, 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 and so on. No matter where you slice it, it only hits once. So this is yes, it's a function, since it passes the vertical line test. All right, so let's move on to the next section here. And on page 2, our goal is to fill in the missing boxes here. We've got a graphical representation. We're supposed to do what's called set builder notation, and we're supposed to also do interval notation. Now, if you look on this first example here, we've got an open circle at -4, and we're shaded to the right of -4. So we've got x values that are greater than -4. Open circle will leave it as just greater than instead of the greater than or equal to. And then to finish this set builder notation off, you tell me the name of the variable and you put set bars around it with that vertical line. And this is read the set of all x's such that x's are greater than -4. Now, when you get to the other version over here on the right, the interval notation, you tell me the left-hand starting point, -4, and you put a comma, and you tell me where it goes on the right. In this case, it goes forever to the right. So you go to infinity, and then you tell me whether to include those values or not. Since we have an open dot here on the left, you do not include it, which is the round version of the parenthesis. And the infinity on the other side is always a round, it's always round with infinity and negative infinity. That's interval notation. Okay, another example. We want the numbers that are less than or equal to 3. So I'm going to find 3 on the graph, and since we're allowed to equal it, I put a solid dot. You shade to the left of that, since these are the numbers that are less than or equal to 3. Please notice that I'm shading on the line, and I put my circle on the line. And there's many more to the left of that, so you shade the arrowhead. Now this starts at negative infinity on the left and ends at 3, so when you come over here you say negative infinity on the left to 3 on the right. You can't include infinity or negative infinity, so you always put round brackets there since it's not included. Every time you think you're at negative infinity, you have to go further. But since you're including the 3, it gets the square bracket, and that goes hand in hand with this side, less than or equal to, when it's got the or equal to, and solid dot at the border 3. Okay, this next one here includes -2 on the left and goes until it gets to 6 on the right without including it. So you're going to do a solid circle at -2. And you're going to go all the way over to 6 without actually including the 6. And it's in between those two values. So it starts at -2 on the left, ends at +6 on the right without including the 6. Now, to do that in set builder notation, you put your x between -2 on the left and 6 on the right. You include the -2 by putting that or equal to, and then you just put the fancy stuff around it, namely the variable repeated and the bars and the such that line. Okay, so that's how you do set builder notation, interval notation, and graphing. Just before I leave here, I'm just going to say I expect all the shading to be right on the line, not above it. The circles should be either open or closed, and they're also on the line that you're graphing. Okay, next thing is a pretty slippery idea. We got to find the domain and range of each of these. And we'll start with the domain. And I think I made a mistake here. This should say range. All right, so let's start with the domain. The domain is a set of all of the x values on the graph. So this x value starting here is at -3, and we're getting bigger and bigger and bigger and bigger and bigger and bigger until we end up way over here, and now the x value is 6. And so the x values go from -3 all the way over to +6. And we're not concerned about the up and down at all. We're just saying it starts on the left at -3 and goes all the way over to the right, and it's at +6. So the domain on this one is -3 to 6, like that. It does include the -3 because at this point the graph includes that -3, but the open circle over here means you're not including the 6. That would be written like this in interval notation. We put a round one on the 6 and a square one to indicate that the -3 is actually included. Now, when you switch to range, you want to know what y values are in this graph. Well, the smallest y value is found down here, and it's a y value of -1. And we get higher and higher and higher until we top out at 7. So it's from -1 to 7. You could go this way also. We have a y value of -1 there and another y value of 7 there. So the y values have a minimum of -1 and a maximum of 7. And we actually reach those two locations. We get down that low and we get up that high. So it's in between, and we're using y values this time. So let me make that do that correctly. We actually include those values. So here's the set builder version of it. And the other one is from -1 to 7, including both of them. So you got to make those square brackets. Okay, let me give you another example of that. And once again, I have to change this. It should say range there. So we're going to first look at this thing, trying to decide what x values are on this graph. Well, if you go this way, you can go forever to the left. So it starts at -infinity. And you can go all the way over to the furthest you can get over is 4. So it's from -infinity to 4. It includes the 4 because you actually have a point over at 4, but you can't include the -infinity. Now, if you think of this, the x values are all less than or equal to 4, and that's how you start the set builder version of it. All of the numbers that are to the left or equal to 4. Now, if you switch the other direction, you can get as low as -infinity by going down this side, and you get as high as +infinity in that direction. So the y values are from -infinity all the way up to +infinity. which is all real numbers in the other version of it. You can do that, or I'll show you how to write it in the other version of set builder notation. I'm sure you'll prefer the first one. The y values such that the y values are any real number. So you have to describe it like that. The easier way is just to put that double backed R. It looks like that, and you can write that instead of all that other stuff. Okay. Identify the x and y intercepts. Where does the graph cross the x-axis? We'll start there. It looks like it crosses at negative 2.5, 0. At 2, 0. And at 5, 0. Those are the x-intercepts. It'll be handy to point this out. We have a 0 for the y when you're finding the x-intercept. Now, in the other direction, it crosses the y-axis at 0, 4. And so there's the y-intercept, the lone y-intercept. And you'll notice that when you have the y-intercept, the x is equal to 0. When you have the x-intercept, the y's are equal to 0. Okay, there are some examples where you're not given the graph, but you're supposed to show algebraically how to find the x-intercepts. If I go back to the previous one, you'll see that to find the x-intercepts, I should set the y equal to 0. And to find the y-intercept, I should set the x equal to 0. It just kind of does a flip-flop there. So I'm going to first of all find the x-intercepts, and that you set the y equal to 0 when you do that. So I'm going to take this equation and I'm going to put a 0 right here. I'll solve it. Add 27 to both sides is how you start this one. Then you divide both sides by 3 here, and you get 9 equals the square of x. And there's two numbers that work. 3 times 3 gives 9, and so does negative 3 times negative 3. So we have two answers, positive and negative 3. And now we combine this information and this information to write our final answers. It's 3, 0, and negative 3, 0. So you can see I use 3 and negative 3 for the x, and I use 0 for the y. Okay, when you're finding the y-intercept, you set the x equal to 0, and this is usually easier. So I'm going to put a 0 where it says x. Our order of operations says to do exponents first, 0 times 0. Then I do multiplication next, 3 times 0. And I'll do subtraction last. So my y equals negative 27, and my x is 0. So it's going to look like this, 0, negative 27. Okay, I'm going to give you another example of this. You're going to set the y equal to 0 the first time. And solve. I'll add 15 to both sides. And now I'm going to get rid of the multiplying by negative 3/4, and you do that by multiplying both sides by the reciprocal. And we have quite a bit of stuff that cancels here. Negative times negative cancels off to positive. 4 times 4 and 4 cancel. 3 and 3 cancel. So you can see that did what we were hoping it would do. We got the x by itself. And on the other side, I'm going to start with 15 divided by 3 is 5. 5 times negative 4 is negative 20. So this is 5, and 5 times negative 4 is where I got that negative 20. So our x is negative 20 when our y was 0. And we set y equal to 0 up here. So now for the y-intercept, you set the x equal to 0, and this is usually a lot easier. So you can see I'm putting a 0 right where it said x, like that. And negative 3/4 times 0 is just 0. After you do the multiplication, the order of operations turns to the subtraction, 0 minus 15, and you get negative 15. So we have a 0 for the x and a negative 15 for the y, and there is our answer. Okay, let's see what we got here. Find the positive and negative intervals on this. So the positive intervals, let me highlight those, are the places where the y values are positive. That's these two sections. And the first one starts with an x value of negative 4. You can see it over here. And ends with an x value of negative 1.5. And the y values at those two locations, both here and here, are 0. And since 0 is not a positive number, we actually don't include those edges. And then we have another one that starts at 3 and goes forever to the right. So starts at 3 and goes forever to the right. And once again, those are not included. So those are the two positive intervals. And now I'll erase those and turn our attention to the negative intervals. Okay, so I'll highlight those in a light green color. From negative infinity to negative 4, and then this section here, you got y values that are under the x-axis, so they're all negative in those locations. So the first one starts at negative infinity and goes to the right until it gets to negative 4. And the second one starts at negative 2.5 and quits over here at 3. I'm sorry, negative 1.5 and quits at 3. So the left x value is negative 1.5, and the final x value is 3. So those are your positive and negative intervals. Okay, I believe that I'm done with this part, and I'll have to make some more of these notes, but let me check. No, I've got another one I can do here. I'm going to take you through this example, and then you'll have to see another video for the rest of this. Okay, increasing and decreasing intervals. The uphill section here, there's two of them, starts when the x is negative 1 and ends when x is 2. So it goes from negative 1 to 2, the uphill part, increasing. And I put round parentheses because once you get up here or even at the start, it's not considered to be increasing or decreasing at the start and finish. It's kind of transitioning. Now another section that's uphill is from 5 to 6.5. You can see the starting x value is 5 and the ending x value is 6.5. And that's also an uphill section. Okay, let me erase those. And we're going to move on to the downhill or decreasing sections. I'll do those in pink. So there's only one. It's from an x value of 2 to an x value of 5. And once again, you don't count the endpoints, so we're going to use round parentheses. Okay, that does it for, I don't know which one this takes you through, but these are kind of in the same order that the review is. So example 13, I'm not sure which one that corresponds to, but you have instructions that match up with this, and you can just find the matching instructions to figure out which examples here go with which problems on your review. Okay, I'll pick this up in another video, and we'll continue later.